In this week's video, we will be talking about manipulating K constants for equilibrium expressions. We will be doing two problems. The first problem says, using the following reactions. And as you can see, we have three reactions with three equilibrium constants. We are then going to calculate Kc for 2 N2O4 gas going to 2 N2O gas and 3 oxygen gases. So how do we do this? Well, we are going to use the idea of Hess's law of being able to combine multiple steps in order to get the overall expression. So let's look at our first reaction. Notice that we have N2O in our product side. However, we only have one of them. We need to have two of those. So we are going to multiply the coefficients of the first reaction by 2. So we will get 2 N2s plus O2 goes to 2 N2Os. But then the question becomes, what must we do to our K constant? Our K constant in this case cannot be multiplied by 2. Whatever we do to the coefficients, we must do as an exponent. So in this case, we will take our K1 value and we're going to square it. If we put this into our calculator, the K value you will get is equal to 9.61 times 10 to the minus 34th. So now we need to look at our second equation. Notice that I have only one N2O4 and I need two of them. So therefore, we are going to do a similar mechanism as we did to our first reaction, and that is multiply it by 2. So we will get 2 N2O4s going to 4 NO2s. Once again, we will take K2 and we will square it as well. So what you do to the coefficients of the chemical equation, you must do to the exponent. So in this case, if I square my K2 value, I will get 2.3 times 10 to the minus 7th. So for our final reaction, you'll notice that I have 4 NO2s on the product side, but now I have to get rid of them by having 4 NO2s on the reactant side. This can be done by flipping the third equation and multiplying it by 2. So I will get 4 NO2s on my reactant side. I will get 2 N2 gases on the product side. And I will get 4 oxygens on the product side as well. So now what this means for this K constant is that because I flipped it, I need to do the inverse, 1 over, but I also multiplied everything by 2, so this means that I need to square it as well. So the correct mathematical manipulation is 1 over K3 squared. If I do that, I will get 9.77 times 10 to the 30th. So now I must verify to see that if I have my overall equation. So let's look for things to cancel. My NO2s will cancel. I have 4 on the product side and 4 on the reactant side of another reaction. I also have 2 nitrogens on each side. Those can cancel. And then finally, I have 1 oxygen in my first reaction. I have 4 in the products of my last reaction, so I will get rid of 1, leaving 3 in the product side. You will notice that I have all of the species that I need to have for my overall equation. At this time, I will multiply all of my new K constants together. Back in Hess's law, you added them. This time you will now multiply, and you'll get an answer of 2.16 times 10 to the minus 9th. Notice that you might have to do multiple mathematical manipulations on the same equation in order for this to work. For our second problem, we are going to use the following equations listed here, once again having 3 with 3 different K values. And we're going to calculate Kc for 2 carbons in its graphite form plus 3 hydrogen molecules going to form C2H6 gas. We are going to do a very similar reaction like we did in our last example. So the first thing that we'll notice is that I need 2 graphite, but in my first reaction I only have 1. So it's best for us to multiply all of our coefficients by 2. This will give us 2 carbon in the graphite form plus 2 oxygens going to form 2 carbon dioxide molecules. This means if I multiply the coefficients by 2, I'm going to have to square my K constant. So K1 needs to be squared, and what I get in this case is going to be 1.16 times 10 to the 7th. Now what we need to do is go and look at our next equation. Notice that it is best for us to look at our third equation first, because what we need to look and see is our product. Notice that I have 2 in my original reaction, but I only need 1. So what I can do is divide that third reaction by 2. That will give me 2 carbon dioxide on the other side, along with 3 waters. Notice that I have flipped this reaction. And I will get 1 C2H6 and 7/2 O2. So I'll take my 7, divide it by 2, so I will get 7/2 or 3.5. So this means that when I flip this reaction and divide it by 2, I need to do the inverse, the 1 over, and I must also take it to the 1/2 power, which in this case is going to be the square root. So I will get 1 over the square root of K3 for this value. That produces a number of 7.91 times 10 to the minus 5th. Finally, for my last step, we will look at reaction 2. Because now I have 3 waters that I must get rid of, I can do that by the waters in the second reaction. However, I have 2 waters, I must produce 3. So what I will now do is multiply my second reaction by 3/2. That gives me 3H2 plus 3/2 O2 and this will yield my 3 waters. So in this case, I've got to look at K2, and whatever I did to the coefficients of the balanced chemical equation, I must do as an exponent. So now this will be K2 raised to the 3/2 power. This will give me a value of 1.08 times 10 to the 7th. So now what we need to do is look and see what cancels. In this case, we are going to cancel out our water from our second reaction and our product water in the third. You'll also see that I can get rid of the 2 carbon dioxide, both on the product and both in the reactant. And finally, you will notice that I have a total of 7/2 O2 on my reactant side, the sum of 2 reactions, and that'll cancel out the 7/2 O2 in my product side, leaving us the 3 species in my balanced chemical equation. This means that my math is good, and now I must multiply the 3 new K constants. If I do that, I will get a value of 9.90 times 10 to the 9th. In these reactions, you have seen how manipulating reactions like Hess's law can really help us determine equilibrium expressions. Instead of adding, you are going to multiply your K constants. Using basic fundamental math terms is very critical. Good luck.